Hello everyone, this is the last example of the chapter. So the problem statement is as that we have a plane with a mass of 8 mg. So that means 8,000 kilograms. The theta is 60 degrees initially, so that means that theta 1 is. And then pullback cable AC is released, so they cut this cable. So this is the state 1. And then airplane starts to swing. Initially it was at rest, so it means that velocity 1 was also 0. Determine the speed of the plane just before it crashes into the ground, so which means that theta 2 is as 15 degrees. What is the maximum tension developed in the supporting cable at this instant? Okay, so the question is that what is the tension? And this is the datum given in the question. So what it means is that we need to take our y coordinate this way. So this is the problem. I mean, if you take y coordinate from here, the problem would be much easier. But anyway, so then y coordinate we will take as from the datum. And then, okay, let's try to solve it. So you can solve this problem. So one is that work energy principle. If you remember, we said that the net work is change in kinetic energy. Or you can use the conservation of energy. So this one is either you can use 1 or or 2, conservation of energy. So here I will use the conservation of energy, but the only problem with the work energy principle is that the sign of work. Okay, that's the only problem, as I said in the previous recording. But you can use this one or that one, no problem. You will get the same answer. Let's start with the conservation of energy so that I can show how useful is it. First thing is that we have the kinetic energy at 1 plus the potential energy at 1 plus the, let's say that potential energy due to gravity at 1, potential energy due to spring at 1, kinetic energy at 2, potential energy due to gravity at 2, and then we have the potential energy due to spring at 2. And then we know that at point 1 there is no spring. There is no spring. And then the velocity at the 1 is 0. Therefore, kinetic energy is 0. And then for potential energy 1 and the 2, we need to find the, let me just show you. We need to find this one, which is yy. And then we need to find generally you can take the center of gravity of the body, but let's go this way. y2. Okay. And then the y1 and the y2 you will use the trigonometric relations. So this will be ay1. So we have the 20 meters. The angle is here 60 degrees. Therefore it is 30 degrees. And then yy will be 20 sine 30, and that is 10 meters. And then similarly for y2. So again it is 20 meters. This angle is given as 15 degrees when it hits the ground. 90 degrees, and then we have this one as 75 degrees. And then y2 will be just the same as y1. 20 times sine 75. Okay. Then if you use Excel, so that is the 75, the radians in 75, the sine of the angle, and then 20 times the sine of 75. 75 radians and sine of the radians, and then 20 times sine 75. That will be 19.3. Okay. So then potential energy at point 1, this one, will be that mg negative 10 meters, because y is that way and y1 is negative. Okay, so y1 is less than 0, y2 is less than 0. And then potential energy at 2, it will be m into g and then into negative 19.3 meters. And then kinetic energy at 2 will be the mv squared by 2. Okay, they cancel and cancel and then cancel. So what you are left with is that then v squared by 2 is equal to then g times 19.3 minus 10. And from here then v will be 2g into 19.3 minus 10, and then that will be 2 times 9.81 times 9.3. Okay, and then square root of that one will be 13.51. Okay, that is the part 1. Part 2 says that what is the tension in the cable. So this is the cable, and then we have an airplane here. So we have airplane. Okay, something like this one. And then forgetting tension. It looked like more like a shoe than the airplane. Anyway, so we have the cable, and then on this cable we have a tension T. This airplane has some weight W. Okay, and then it goes this way.